Okay, so this is for 2D incompressible fluid. This is the conservation of mass equation you get. So one thing people did was move this to the other side just like this. See how there's a negative right there because it was a summation that's positive. And then what people said is I'm going to say that u and v come from differentiating a special function called the stream function. So that means, and it's defined in a certain way such that it always will satisfy this equality. So, right, a stream function is just some function that defines, here's y, here's x. So a stream function is something that is just, right, it defines contours, or it's really a surface, but you can define these contour lines that look like here. So it's a function of x and y. Now, it's the important thing about stream functions is it satisfies these fundamental relations. I'm going to say that the u velocity, or this x direction velocity, is equal to the y derivative. So this is x, this is y. This is the most common thing that first is mistakenly, for an x direction velocity, people take the x direction, the x derivative. Don't do that. Stream functions are defined sort of in an opposite way. And then I say the v velocity, the y direction velocity, negative x. So these are the stream function equations that are used for all stream function analysis, right? It's just a question of figuring out what that stream function is. And the reason you do this is because now instead of having to find u and v, all I have to find is one function, right? You just now need to tell me what the stream function is, and then I can tell you the velocity in the x direction and the velocity in the y direction. In the notes I have, I mean, it's not that hard, so, right? You can sub this into continuity, and you'll see that it's always satisfied. And it's satisfied because, right? You get this relationship, and order doesn't matter for continuous functions. So because of that, right, stream functions all satisfy continuity. You just need to figure out what the stream function is. And usually how this always goes is maybe is your prescribed either a stream function, and then you have to take derivatives, and then you can tell what the velocities are. Right? So I think I'll actually stop here.